which I don't in the book talk about this, but there's a thing called the Feynman path integral, which is actually how we do quantum field theory, which is like how if you know that a particle was at a position A and a position B, to calculate the history, i.e. the deterministic picture of where that particle was, not where you could measure it, but where the wave equation was connecting those two positions. You have to add up, I'm not making this up, okay? Just bear with me. You have to draw every single possible pathway in existence that particle could have taken between point A and point B. And then you weight it. You weight each pathway with a probability that depends on an imaginary number in the exponent.
Weird.
So now it's the validity of the pathways that goes to zero at crazy pathways and converges to the classical pathway at like high amplitudes where the exponent, where the probability weights are all sort of adding constructively instead of like destructively adding. And that wildly complicated way to get back to like normal classical behavior is the best way we know how to describe how atoms move.
What? I'm sorry, what? So, okay.
Do you see where we're going with it? So go back to the thought experiment. You have this picture of like just a particle that just goes from point A to point B in a straight line. It looks very simple, and I can think of a million reasons that particle may have gone from point A to point B. There's a force on one side, and it's just moving in a straight line, and it's a really nice even force. What Feynman said and what the math says is, no, you actually have to think of all of the crazy things that the toy could have been doing.
Right.
And then tune the knobs in the right way so that it gives you the straight line. And that is the proper solution to that problem of where the particles could be. If you went back and tried to measure it in between, you'd find that it was not a 100% probability of being in a straight line. You'd find that there's like some probabilities of it being off on a whirly-do or a loop-de-loop or whatever. Or going off to outer space infinitely far away and coming all the way back and landing at that spot, all in a blink of a moment, right?
Right.
So
interesting.